Yeah, so this is my presentation on formerly the future of learning Arduino, but I call it Fluid Logic now. So let's see, how does this work? Yes. So this is a process gateway where I will explain what the progress is so far, what my design direction is, and what my future actions will be. So on the timeline, we're now kind of at the end, scary. So what I still want to do is video prototyping, storytelling, and user involvement or testing, perhaps online. And what I did is desk research, interviews, field research, explore the aesthetics. I did a workshop at Arduino, did some prototyping and ideation, did more prototyping and ideation in the last phase. I didn't do as much involvement as I wanted because some teachers were not responding yet. So that might come in the later phase as well. So my design question right now is, how might we create tools to enable fluid and social physical computing for design-based learning class students 14 to 16-year-olds in high schools? So I chose this design-based learning class based on the research that I did in the different classrooms that I observed. Arduino or physical computing is usually promoted as a tool for doing this, but the current tools aren't really supporting this way of thinking or prototyping, especially when you think about group work. And for physics, computational thinking, and technology, there's relatively a lot of solutions out there. So how does this Technasium design-based learning class look like? It has like some tools, Fab Lab, and it has tables. So you can, this is just to get a general idea on how it looks. And these are the projects that they make. So there's also physical building involved usually. So the main goals of this design-based learning class, also from speaking to the teachers in the research phase, is to make students curious. So let them learn these skills so they can apply it later on in their own projects when they are more freely about choosing what they do and how they do it. From learning to learning by. So how can you use this class to make them learn concepts that they can use in other fields? So trigger ways of thinking, problem solving, working together. And make programming collaborative. So make students understand that it's not only about the result, but also about teamwork and how you got there. Why physical computing? I think it's real in its essence because it's not a mathematical model of reality, but it's actually the reality that you're digging into. It's multidisciplinary, so it connects different fields in the high school, such as physics and this design-based learning class. So it brings stuff beautifully together. And it's everywhere. It exists everywhere in the real world, and it's influencing people's lives. So in that sense, it's important to know how it's working and how you can influence that and learn to play with it in a way. So what I'm focusing on is the future high school education. And I want to focus a bit on education-led innovation. So what if we would define education as the leader in innovation? That would then trigger future industry to have a different aesthetic or a different way of working. Because if we just focus on teaching it for the current industry or focus on sort of industry-led innovation, then you get a different type of aesthetic, I think. What is happening right now is an empirical question. What can happen is a technical question, but what will happen is a political question, depending on social choices. This was from the book Mindstorms by Papert. I think it's really interesting to it shows, he also used this metaphor of the QWERTY type keyboard that is just defined by history. And it's not really a choice that we made, but it is because it's dragging from the old industry. And that's also what I try to avoid with this education-led innovation, that we actually focus on where we want to aim at instead of taking the old concepts and polishing them a bit. Because tools define our imagination. So the tools define what we imagine, and our imagination defines the tools we explore or use. So this is kind of a loop, but I think it's interesting to sort of break out of this loop and have different tools, and then you also get different imaginations of what is possible. So programming today looks hard. If you look at it, it's usually written text that is not that readable. it's fencing it away from others. It's usually on a laptop, and it's like your own silo of what it is. So what we recognize as code is what programming is, and what the job looks as well, which is kind of defined by this aesthetics of what it looks like. What is important in future programming? So if you listen to speakers talking about this sort of future of programming, they all talk about test-driven development. So how can you use tests in the process to make sure that you achieve the goal? How can you do pair programming? How can you make it more inclusive? Especially the gender divide is an interesting sort of exclusion right now. And how can you have empathy with the users or with the customer in an early stage? So this is important for interaction design, this project, because it's heavily about representations of interactions. And our industry is heavily influenced by the tools that define our imagination, mostly coming from the tech industry. And it's setting an example of how programming or defining behavior could also look like. It's important for design-based class students because it helps them to have a different framing of what computing is about, and it might help them to understand the world around them in different ways. So the goal of this project is also to change the way programming is perceived, how students work together, to make teachers focus on teaching instead of focusing on technical support, and make it more motivational. So this was during the last presentation, where you have this fluid social diagram, and the two prototypes that I built at that moment were kind of parasites that were focusing on movement is more than the shortest path from A to B. So how can you make that in different scenarios? So I made these two little prototypes. That one was using presentation as a way of coding, and the other one was using Photoshop or graphical tools as a way of defining behavior maps, and in that sense, defining what coding is, or reimagining what coding is. Then I also built some side projects in the after that presentation. So I shared on GitHub some ideas on what could happen in the current world with the current reality. And I was writing this paper on the balancing act of technology education using Arduino, which was more on the sort of side of the teachers and how they sort of negotiate between different balancing acts in their practice. Unfortunately, the conference was not continuing because of Corona, but it was still a good exercise to sort of write down the thoughts from the research. So these were the what ifs in the last presentation. What if you could understand behavior or logic through playing with it? What if you could understand code through more than seeing symbols? What if coding is like acting out a scenario? So to sort of go back to this scenario of how a coding class looks like, there's this video.
Well, I your program on my own because you need to fix the other things. So it's still like you're not always working as a team, like those roles, even if you don't kind of want to. It happens really easily.
Yeah, true.
But can you describe what you want to do as a group?
Not really. I think.
Okay.
Sorry, I was just getting some inspiration. So one of the groups is doing something about like you can knock.
Yeah, and the goal can be really hard, like deciding what you want to do. But even if we decided that, then trying to kind of divide the tasks.
Shall we do a log system?
So in the scenario of a class, you have to form groups. You have to connect and explore what is possible. Then you have to discuss and record what you want to achieve as a group. And right now you do that verbally usually. But I think it's interesting to also already bring the tools in as a way to sort of start this discussion and record what you want to make. And then you can tweak it and you can present it. So I will go through these different steps. So right now, if you form groups, there's usually one student that takes the role of coder. And in the future, I think it's interesting if everyone takes part in defining the behavior. So everyone is sort of co-owning this behavior artifact. Connect and explore. So the possibilities are now explored through symbolic writing or not explored at all. So this step is then skipped. But I think it would be interesting if possibilities are actively explored by controlling the hardware, and then you see what it can do and how fast it can move, what kind of sound it makes, or what is possible with it, basically. Then you would discuss and record your scenario. So right now, sequences are described by writing instructions. But I think in future it could be interesting if we focus on scenarios. So test cases are communicated by recording the test case then. And then tweak it. So logic is now defined by writing instructions again. But logic could also be defined by making the testing and tweaking the timeline and perhaps doing more tests so you have a better understanding of what the different paths are through this interactive artifact that you're building. Then it's about presenting. So right now it's hard for other students to grasp what is happening in the code or what it's actually going through. But in the future, you could have rich interactive ways of seeing the process and the iterations during the project, because you documented everything as well in this sort of way of acting it out and videoing it. So the touch points are how to control the components in the connect and explore phase, how to record the behavior in the discuss and record phase, how to Wizard of Oz the behavior, and how to tweak the behavior. So how to use the recorded tests as a working material to tweak. Then you have the different roles in these different stages. So in the connect and explore, you probably have an electronic builder, a mechanical builder, a tester that is then trying out and exploring, and a documenter. And I think it would be interesting to switch these roles around in the group so everyone has the ability to explore these different parts of it. And in the discuss and record phase, you have the user, which is then trying it out and acting like a user. The wizard, which is then Wizard of Ozing the interface or the response from the system. And the documenter, which is then documenting everything, again by video or some other way of having rich documentation on what it is that you're building. So again, this question, so what we think is fluid, and in the last presentation, I defined it as it's easy to craft and change, intuitive to understand, usually visualized or made tangible. And I think this is why computers are so beautiful as well, because computer models seemed able to give concrete form to areas of knowledge that have previously appeared so intangible and abstract. This was in the 1980s. But I think, did we really reach this? Did we really give concrete form to things that are intangible and abstract in the computer science field or in computing education? So what I want to focus on is how to make these tools more fluid by making them more interactive. This is known in programming as called interactive programming, where you could like live edit what it is that it's doing and increase the visibility. So you can visualize the program, or you can simulate the program or the algorithm. So one example of that is this, where you would have increased visibility and you can hear and see what is happening, because you can have your phone next to the Arduino that is then showing what it's doing, and you become more aware of the different steps that it's going through. So I think debugging should happen by default instead of defining exactly what or when or what you want to debug. Debugging for beginners should focus on showing everything that might be relevant, making it visible and making it contextual. So in this scenario, it's contextual because it's next to the hardware. It's by default because all the ports on the Arduino are visible and all the use ports are interactive in a way. And you can see and hear what is happening. This timeline metaphor as well is like how you would record it or how you would explore it or use test case scenarios to build your program. So you would have the inputs, the data, and the outputs, and you would use these test cases. So you could actually have the video at the same time as seeing the ways the ports are being manipulated. And in that sense, you can have a better overview of what this whole program is about. You could have different test cases. So you would have the perfect scenario where the user would just do exactly what it needs to do to make it work. But you could also have different scenarios which are more like random presses or a repeated try of this concept. And you have really contextual documentation because you have this video and these frames that you can sort of slide through and see what's happening at each moment. Also, this intent dialogue could help you to sort of see what is the consequence of different actions. So you could, I'm still figuring out how to exactly do that, but this could be generated by this programming by intent system. And it can also be created by the user by defining what was the intent on this interface, perhaps. So social versus individual. So the tools should invite others to join the crafting. So right now, it's usually the case that only one person can interact simultaneously, which creates quite a individual experience. So tools should force or allow for switching roles easily as well. And tools should allow to share and see progression over time. So imagine doing a physical computing project is like creating music in a band. You start with exploring the instruments, then the instrument starts, you start playing together, and then you start to write down what worked. You start to sort of write down the notes. So what are the instruments, what are the different roles, and how can you build the symphony in the end? So perhaps you could see it as people get different tools based on what role they have. So the tester might have a different tool than the connector, which is more about, okay, what is the electronics doing and how can you connect this to the Arduino? And the documenter might use some kind of video or annotation, a bit like a Snap filter or Snapchat interface where you could record what it's doing at a certain moment. So how will it work? So I've been looking at projection-based interfaces as well. I think the cool thing is that you can use the full area of the table. Everyone can look at the same information. It's pointable, but it's harder and more expensive to set up. Smartphone-based could be cheap because it's usually already in place in these schools. Students have smartphones. It makes it easy to switch roles because each interface could have a different role in that sense. And then you can make each interface have a different role by just setting that up in the technology. And you can still use individual devices, or it's still an individual device, so you cannot work really together. It's still, you are all doing something different on your own device. Tablet-based, it has a bigger screen for interaction. More people could look at the same info, but it's still mainly one person that is interacting with it. So I think I will mostly go for the smartphone-based solution right now because these aspects of it, that is quite cheap and it's easy to switch roles. So that's where I am now with Fluid Logic. So I want to do more video prototyping, work more on the storytelling and more user involvement or testing with either the community, teachers, people that are perhaps also people that have been thinking more about this for a longer time. So in the future, I still need to define these behavior constraints in the timeline better, define better how working together in this timeline metaphor would look like, because you have all these instruments and you're playing together, you're being the wizard or the user, but then how does it come together when you're doing this tweaking in the timeline? And I can explore more visual styles for the interfaces. I now took a familiar one, which is like the Premiere Pro one, but I think it's interesting to explore more different visual styles that would perhaps engage different people or more people. Yeah, connect to more other people, get other perspectives, make a concept video, preferably with students of the right age group. I'm curious if that's still possible, but let's see. And work on the report. So that's where I'm at right now. Thank you.
20 seconds.
Yeah, I have more slides if you want, but it's more like to go through if you want to dig into a specific area.
Right. No, very clear, concise presentation, Geert, of something that you explored a lot of different things, and you're now telling a pretty linear story of where this is starting to land. So thank you for being very clear there. That was the 20-minute mark. Yeah, no, I have no, I don't see any problems here. I think you're exposing a very clear logic to the project. I have more question. I have a question around the general. One thing in the general rhythm of the project. So on one hand, you have this vision of making it very fluid and let's say tangible and socially embedded. Looking for this, very different aesthetic from what it is now. Mm-hmm. But then in some of the presentation at the end that you now showed, it returns back to the current physical hardware. How I see a bit of tension there. Do you understand what I mean?
Yeah, I see what you mean. I think I'm not gonna redesign the hardware. Partly because that's really hard from distance, and partly because I think it is also really good if it would work with the current hardware, right? I think if you would, and it also partly because I think there's so much richness in learning this real hardware as well. We can hide everything into boxes, and then we're basically making a Lego Mindstorms, which is cool, and it has its place. But I think that's also cool that you learn about electronics and you learn about how to connect this stuff together.
Yeah.
So it's showing this messiness of the reality. But on the coding side, it might become more fluid.
Because in a way, you could also say that this paradigm actually requires rethinking how we make machines. I mean, digital processors are not the only way of handling and automating things. I'm thinking parallel processing or non-binary.
Yeah, and I think that would be valid, but you would still have same types of visualizations. Yeah, then it could become more tricky, right? But I think you would still, whatever is happening behind the brain, you would still have inputs and outputs, and you would have different types of inputs and outputs that are either analog or digital or whatever. This example is really digital, but I could see this work for really analog inputs and outputs as well.
Yeah. So these are not comments. These are not critiques. These are, I think, things you could polish up, or maybe you will do. Is that you keep some frameworks in place, and others you're pushing.
Yeah.
And in setting up the story, you can be even more crisp in, these are the things I'm going to be working with, which is the style of determining what needs to happen and how the roles are exchanged, or how do you say, distributed between the people involved. I think those are your main things, but there's other things that you will keep in place. And then maybe in a reflection, you can also talk about how maybe keeping some frameworks in place actually makes it difficult to reach what you want to reach or not. Because at some point you're gonna sort of put a no, let's put it this way. I heard you wanted to make a comment, but one thing is, to what extent are you creating a thicker layer between what is actually going on and how you determine it? And at a certain point, that might really get in the way of getting things done.
Yeah. I think this thicker layer is already existing. It's just the representation of that layer is through text. And I think that layer could have been thick in a different way, right? It's just, it might have the same thickness, but just a way of representing it.
Yeah.
is
Nice.
what I changed.
Well answered. Who was commenting?
If I could just mention, I like the realizations that Geert has shown about the problems that students have getting into this, and I like that he's addressing those things. Arduino started allowing, I mean, previously or since the beginning, Arduino can illustrate what values it gets by printing out numbers, but they added this function for making a graph, and that in itself makes a huge difference for people, just that little difference. And what I see of the ideas of how to divide the work and how to illustrate things, I think can absolutely be a beneficial thing, just to get people going. But I see your point in that this becomes also a higher sort of level of, like a high level language, in that you're getting, like you're saying, there's more in between. But the way I see it is that this is a way to get people going, where they would otherwise just feel that this stuff is cryptic and I can't get anywhere with it. So personally, as a teacher in these things, I really like the things you're addressing and how to help people get going into working with these things and realizing the parts you have in this, like the physical building, the trying stuff out, see what can you do, and then actually start thinking about what I want to do. And those parts is often something that students have problem to realize. They just want to build the thing they have in their mind, and then the whole learning thing is just in the way.
Yeah, I totally agree with you, Rickard. I think there's a lot in this concept direction that meets with also the things that Geert tried to set out, like at the beginning, set out to do. I totally agree, and I think it does it really well through the process of finding all this. But my comments were merely sort of trying to poke a little bit of some, like, framing a bit more. This is not, again, it is a different version of programming, and it's not going to be the final solution, but it does really emphasize another way of working that I think is very valuable. Absolutely. So
yeah. Could I add a comment also on that?
Yeah, we have a few minutes.
Yeah, sorry. I think I really appreciated this since the last time I saw. I've been sick for a couple of weeks. Sorry for being absent. But I absolutely love this direction towards the smartphones. I know it was like more on a sketching board and discussion when last time we spoke, and I really like this direction. I think it's really strong in this area. And regarding Stoffel's comment about staying with Arduino in this particular, like Arduino Uno, and I think that's perfectly fine since you're working with Arduino and the future of Arduino. You're starting with this particular, it's the most common board in education. It's like a scenario that people can see and recognize and understand sort of immediately, as this is another way of working with what we have, kind of. And I see it kind of, I mean, there are lots of different Arduino boards and shapes and, LilyPad and whatnot. I think it could be really easy to, now it gets very practical, but when you select a board in the Arduino environment, you could be able to select, and then you select different types of boards, right? Do you hear me?
Yeah.
You select, you could imagine having, you could just like easily make a sketch with having the same setup, but with different types of boards. You could even have like other things that aren't even Arduino as a visual representation. I think the concept and the idea isn't limited to this particular form. Of course, it's still a board, but I think I really like this, the way it's making things closer to the design. And I think you could, making a vision about the future of programming or learning programming in this setup, I'm pretty sure you can make a really amazing concept video based on what you already have almost.
Yeah.
So I'm very, very happy to see this.
I agree. So, Geert, no red flags here.